Hey there, geometry. We are working on lesson 12, which is radian sense. So we talked about radians in lesson 11, learned what they are, which is a ratio between the arc length and the radius. So the central angle measured in radians is the ratio between the arc length. So this would be is the ratio between the arc length to the radius. Okay? Alrighty. So, which one of these doesn't belong? As I said, these are my favorite things to do in class because it's a great discussion. Like, it's just so much fun to talk about, like, which one doesn't belong and why you think about it and yada, yada, yada. Well, I don't know. Like, this one is here is like a central angle measured in radians. Here you've got the arc length over the radius, which if we did the central angle, it would be pi over 2 over 1, which is just pi over 2 radians. So I think that one could belong because, you know, it's in radians. This one's in degrees. You're not given the arc length or the radius, so I think this one doesn't belong. Here you have 1 radian, so I bet this is 1 unit over 1 unit, because the central angle, which is 1 radian, would be 1 unit over 1 unit. So that's my assumption, but it's always such a great discussion to have in class. All right, so let's look here. Degrees versus radians. This double number line shows degree measurements on one line and radians on the other. So we have degrees and radians. Fill in the radian measures on the bottom for these measurements. Okay, well, we know that because we've done in the past. If I draw a circle, if we start here and go all the way around the circle, it's 2 pi. So I can say 360 is 2 pi. 180 is half of the distance. So if I do half of 2 pi, it's just pi. Now, if I do, let's say, half of that again, it's pi over 2. And if I try to do a fourth of it, it's actually 3 pi over 2. And 0. So if I erase all the gunk that I don't want to see anymore, okay, that right there, I'll erase that too, just because. These are the things that we have to remember. We have to remember them, We have to remember them for our geometry class, and especially for classes we take after geometry, because it's very, very helpful to remember the radians and how they relate to the degrees, especially in what we call a unit circle. Okay, unit circle being, this would be 0. We come back, we have 2 pi. Over here we have, pi, pi over 2, and 3 pi over 2. Okay, those are the 5 measurements that are really important to memorize. All right, so let's look at number 2. Express each radian measurement in degrees. So when we want to change things from radians to degrees, we actually need to multiply it by the ratio. So I have pi over 3, and I need to multiply it by pi is equal to 180 degrees. Or I could say 2 pi is equal to 360 degrees. Okay, this one right here is the most useful one because it's just pi, not 2 pi. So I can say pi over under 180. And I put pi under 180 because when pi is on the top here, it's on the bottom there, they cancel out. And that equals 180 over 3, which is 60 degrees. Again, another very useful thing to do, not only in geometry, but in math classes in the future. All right, how about 5 pi over 4? well, pi is on top. That means I need pi on the bottom times 180. That should be a parenthesis. Pi. Ooh, that's messy. I don't think 4 goes into there evenly. Handy dandy calculator, just because it's been a long day. That's my excuse. 5 times 180 divided by 4, 225 degrees. Cool? All right, so we got that. Now, we have things in degrees, we need to express them in radians. And as we've said, radians usually have a pi in them. So when I want 30 degrees, I need to multiply it by degrees on the bottom, radians on top. Okay, so if I simplify 30 over 180, that's actually pi over 6. What I can do there is do 30 divided by 180 and change that into a fraction, and that gives me 1 over 6. And I need that pi over 6. All right, let's do 120. So I have 120 degrees. I want pi, or pi on top, because that's what sort of signifies things being written in radians, and 180 on the bottom. I know the zeros can cancel. That gives me 12 pi over 18. If I simplify that, I think I can put 6's into them. 6 goes into 12, 2 pi, 2 times, and 6 goes into 18, 3. So that is my answer. Cool? Cool. All right, pie coloring contest. Your teacher will give you a set of cards with angle measures on them. Place the cards upside down in a pile. Choose one student to go first. The student should draw a card. Then on either circle, shade a sector of the circle whose central angle is the measure on the card that was drawn. Take turns repeating the steps. If you are shading in a circle that already has a shaded sector, choose a spot next to the already shaded sector. Don't leave any gaps. You might have to draw additional lines to break the sectors into smaller pieces. Continue until an angle is drawn that won't fit any of the yada, 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 yada. Okay, when you are finished, answer these questions about each circle. I'm going to put a Google Doc in for you to work on, okay? And you can just turn it in from there. Okay, this will be part of your homework, all right? And that's it. Okay, good job today.